Hi, my name's Nathan. I'm a senior digital artist on the special projects team for Weta. I've got about 16 years experience in the film and games industry. Of that, I've probably spent a good 7 or 8 years in Weta's models department doing hair and fur. I've done everything from complex braided grooms for the Hobbit trilogy to every kind of ape you can imagine in the Planet of the Apes series. In recent years, I've moved more towards the real-time world. Just looking at how we can kind of take that film knowledge and push the visual fidelity as far as possible in a real-time workflow, and how those workflows can work together to benefit both sides. When Unreal came out with their strand tool, I was pretty excited. I thought that was a great opportunity to apply that skill set in a different way, and Weta was really excited as well. And Epic had asked us to partner with them in the development of that tool and take some of that film knowledge and see how we can improve the tool. This gave us a great opportunity to do an animated short with some furry characters, so we started the Meerkat project. Our partnership with Epic goes back a number of years now. We found them to be really great collaborators in helping us push what we can be doing in the engine. For this project, we opted for off-the-shelf tools to see if the gains that we were getting were truly applicable to anyone working in the engine. We're happy to see that they were, as we've seen from all the people who downloaded the full scene and produced something amazing with it. Traditionally in games, hair has been done using cards, which is basically a polygon strip with a picture of hair on it. It's a very, very difficult skill to do, and to do card hair really well takes a lot of time and work. But ultimately the strand-based workflow allows you to have every single strand be individual and unique, and it just offers a level of fidelity that you can't quite get from cards, and it also tends to light a lot better as well. We see in film that we can pretty much achieve photorealistic hair and fur, so being able to take that skill set and apply that in a real-time use is pretty exciting. So let's have a look at how we built the Meerkat and the eagle.
So I'll just go over the basic workflow for making a groom for film. If you are a groomer in the film industry, this stuff is pretty familiar. It's a pretty standard workflow. If you're new to strand-based grooming, then this is kind of a brief overview of the process. It's not meant to be a tutorial. The first thing that you're going to do is gather reference. If you're making something real world or not real world, you will still ultimately want to ground your work in reality to some degree. So having a ton of reference will help you create a more believable creature. In our case, the Meerkat's pretty straightforward. You just start pulling reference from Google, trying to find some key interesting pieces that you want to match. We were fortunate enough to be able to go to a zoo, go inside the Meerkat enclosure and capture some high quality photography. I use PureRef. I find it's a very, very good way to pull images, organize them, zoom in and out, and kind of just collate it into one easy place. So you can see it's a whole variety of reference images all sort of combined together, and from that we pick out a few specific reference images that we want to match that just sort of encapsulate the shapes and forms of the meerkat. You can see through the chest area there's a certain flow to it. It flows up into the shoulders and the neck and then bends around and flows down. Same thing through the abdomen, it bunches up through the center line here. So we just select a few of those, covering most of the angles. Some of them show good silhouette fur, some of the bunching that happens, and obviously capturing the feet, the hands, and some good close-ups of the face.
So when building out the actual model, in this case I was lucky enough to be able to do the model and the fur. That's not always the case. Sometimes you'll have a different artist doing your base model and then another artist doing the fur. But in either case, it's important to consider the pose that the creature's in. Particularly for an animal like the meerkat, where it has such an extreme range of motion. It can be fully up on its feet, straight up, and also fully down on all fours running around. So in this case, I opted to model it with more of a 45-degree posing, so it's kind of halfway in between both of those extremes. The same thing with the hands. The hands are bent sort of halfway, not fully flat, not fully straight. The main reason for this is that once you actually groom it and you have it animating, you kind of want to split the difference between the poses so that you don't get a situation where you've modeled it for one extreme and then when it bends down and changes into a different position, you stretch the fur in an unnatural way. So you get big areas of no fur or really stretched fur. So in this case, it actually worked out pretty well having it at that kind of 45-degree angle.
Before we start grooming, we want to make sure that we've got a good base to work from. So we'll take the main Meerkat model, make sure that it's got nice clean topology, and then we'll start by stripping out all the extra things that we don't need to grow fur on. So getting rid of the toenails, fingernails, eyes, inside of the mouth, that kind of stuff. That'll leave us with a separate piece of geometry which we can call the fur geo, and that just represents the area that the fur is going to grow on. In situations where you want to paint maps, you'd ideally want to have that in 0 to 1 UV space. So when we're happy with the UVs, happy with the base geometry, we can start to grow fur from it. From there we can build the groom out. I obviously can't go through the whole process in this talk. It does take quite a bit of refinement and back and forth, but I'll go through the basic approach. This applies across most grooms, from creatures to human characters. And I'm using Yeti for this project, but the general principles do apply to most other grooming tools. Our Meerkat was actually a pretty basic groom. Using the reference, we just start by laying out the guide curves. These guide curves define the flow or direction of the fur as well as its initial length. The actual fur is interpolated from the guides, so one guide could control hundreds or even thousands of the actual strands. The more guide curves you use, generally the more control you have over the shape of the strands. And the guide setup is pretty vital in creating a good foundation to build on top of. So spending a lot of time on getting the guides right will just add to the believability of your groom. As you can see here, we've got a subset of Molly's guide curves. From the reference that we saw, you can see that there's those distinct flow changes that are quite characteristic of the Meerkat. So when you're building out your guide curves, it's important to make sure that you can identify those unique features and replicate them. As we saw, the bunching towards the center line of the belly, those directional changes through the chest area, additional bunching on that neckline as it transitions from the front of the chest through to the back. So just making sure that you capture all of those is going to be key to making sure she looks believable.
So if I just quickly start fresh, I'll go over that basic process. If we click on the fur geo and go add a groom, I'll just copy this for now, and we'll just call it this. Now over in the attribute editor, when you click edit groom, and you've got the tool settings bar open, you'll get all the Yeti options in here. So this controls how the brush works. It has some of the grooming tools here, the attribute paint tools. That's your main sort of tool set that you'll be using to do guides and to paint attributes. For the actual groom node, we want to turn conform strands on, and I'll show how that works. But it basically means that as you sculpt a few curves, when you click to add new ones, they will basically conform to the shape of the existing strands, and that makes the whole process just a bit faster than having to manually sculpt everyone from scratch. I generally turn create mesh vertices off, as we want to be able to just place them where we click and not necessarily at the vertice on the geometry. I probably want initially 5 segments for the strands when they go on. So from there, I'll do that little belly area where the fur kind of bunches up down that center line, because it's a little bit of an interesting area. Over here in the tool set, we've got plus and minus. The plus simply adds a guide curve where you click. So I'll just add a couple of guide curves down here. There's a whole variety of tools. There's a comb tool, which is pretty self-explanatory. You're kind of just brushing that guide in the direction of the comb. The one I tend to use the most is actually the move tool, which functions similar, but it's kind of not surface based. You can kind of just push the curves around a little bit more freely. So if we just start to create that initial shape through here, just getting a sort of a base to start from, and then as you see here with the conform strands on, if you click to add new ones, they will kind of flow in the direction of the existing ones, and that you can kind of just tweak them a little bit without having to completely redo it. So if we get some of that there, and then we'll add some more on the other side. They'll initially conform as well. And then you can actually isolate, select some, and then you can brush them independently without affecting the other ones, so you can get that shape a bit more accurate where it bunches and pushes them together. And just checking all your angles. Turning off this isolate select and get them all. And that's kind of basically the process for it. If you want to put a larger volume of them quickly, you can just have a bit of a larger radius and just paint them in quickly, and then use the chrome tool just to give them a quick shaping, move tool. You can just flow it and contour it over the body. And that was pretty straightforward. It's really easy. It's kind of fun. And then if we just hide the test, you'll see with many more hours of work and the correct length and things that you build out the whole shape. You can see there's that through there. And the stuff that we sort of identified in the reference through the shoulders and the chest and all that stuff. Same kind of bunching. So the exact same principles apply that I just did then. You're just placing and brushing. I personally use quite a lot of guide curves. That's how I work. You don't necessarily need to use nearly as much as that, but I think it's a little bit of personal preference. There's no real performance benefit, at least on my workstation. So just use as many as you feel you need to kind of capture that shape and try and get a lot of the unique subtleties and shape transitions.
When we have the guides in a good place, we can generate the actual strands. From there we add several layers of clumping and noise, and then spend a lot of time painting in those attributes to create variation in those main structures, depending on where we see more or less of that textual breakup in the reference. As you can see in the chest and belly area, it's shorter and smoother. On the back, it's longer and has that layered structure with a bit more clumping. We also get that tighter bunched up clumping through the lower belly where the direction changes.
So I'll just quickly show you how the attribute painting works, as it's quite an important thing. If I just hide the groom and show the base guide curves, you'll see that each guide curve also has an attribute value at the bottom of it. You don't have to necessarily have the two connected. You can create a separate groom node that is just for attribute paintings, but in my case I've got so many curves I just kind of use the same groom node. But if I hide the strands, you'll see there's a bunch of colored dots on it, and that basically defines a value for a certain attribute, like the clumping or the noise, for example. I think it goes from dark purple to orange, and that's basically 0 to 1. If I turn the heat map off, you can see black means the effect is nothing, and 1 mean the effect is at 100% based on what you've defined in the node graph. So it's a bit easier to see with the heat map on. So if I click on some of these, you'll see, for example, that's the small clumps weight. So in this case, I've got a lot of small clumping through the back. You can see a little bit of variation through there, and that's what I was kind of talking about, getting that breakup. So we see the green and the lighter greens, the yellows, the oranges. That's the variation in how much and how intense that effect is from those small clumps. And then I've got much less through the belly, much less through the arms, where we saw that smoother fur. So if I go through the attribute list here, you've got that master scraggle. I've got it pretty much everywhere. There's a bit of variation in the master scraggle node, but it applies almost everywhere except for those really short fine hairs on and around the face. Small clumps, some variation across the whole body, even where it's mostly applied across the back, there's a little bit of variation there. Large clumps, same thing. Master density, I've got a little bit of change in a couple of areas. Micro scraggle, much less scraggle through the face. So yeah, just kind of the bunching, the flow bunching, that was something that we really identified in the reference. So it's highly applied through the neck area, obviously through that center line. There's a bit on the eyebrow area, and then just a couple of random spots, like just manually painting in several random spots just to give that clumping more variation. And I think that's just pulling the clumps tighter, so you don't see the whole leg through here having the same looking clumps. You've got these patches where it's a little bit more, a little bit less. So I'll actually just do a quick, I guess a really exaggerated example of how that works is we saw all the clumping on the back. So if I just click on the small clumps, set the value to 0, it's on 0, and then just paint out all of that through here. And quickly, same thing for the large clumps, we'll just paint that all out so you can really see how that works. So if we go back to heat map off, black. So basically the effect of the small clumps and the large clumps is nothing in those areas. And then if I turn the groom back on, we can see that it's basically removed almost all of the clumping through the back there, and it's very smooth. So I hadn't entirely clipped where you see some of that clumping, but you get the idea. That's kind of up here's what it looked like. And then as you paint those values, you change the effect of that on it. And that's basically what's been happening over the whole body, just to create all that variation and uniqueness. Up on the face, you can see that there's quite a bit of variation in how the clumping is done up here. So you can see on the cheek where it's a bit longer towards the back of the cheek, you've got some clumping there. As it transitions forward towards the nose, you have a little bit less of that. It starts to loosen up, starts to get a bit shorter, and then it changes direction through the mouth area and up onto the nose bridge. Within the clumps themselves, there's quite a bit of variation. I think this groom as a whole actually only has 3 clump nodes, and each of those nodes has a little bit of variation in how the clump's done and its radius, it's how tight it's clumping, where it's clumping along the strand from towards the tip to the base. So combining those 3 together, you can kind of get like some larger clumps that are a bit more broken up towards the end. You can see some of the smaller sub-clumping that happens inside the larger clumps. You have a few that are a bit tighter, more pinched up, and all of that variation is coming from the painted attribute maps. So you paint a little bit more of the larger clumps, a little bit less of the larger, a little bit more of the tighter clumps, and then overall you get a lot more variation. You can see as it comes down and transitions towards the neck, some of this is a bit softer, where it might be rubbing against the neck fur as well. Over here towards the shorter hair, you have very little clumping because it's all just very short hair. It's pushed along one direction. Up on the brow line where it's a little bit longer, again you see some of those clump shapes. Through the head, top of the head, it's still quite uniform, and it's uniform in the reference as well, but it's all not exactly the same. So you can see here's like a small tuft that's a bit different. Here's some shorter ones, here's some more tufted ones. Like there's just enough variation in there that it doesn't all look exactly the same, even though it's actually quite a smooth surface over the head. And then down through the neck, same thing sort of happens, and then towards the back where it's a lot longer, you can see some of those variations in the direction that we did in the guide curves. So you can see there's some longer ones through here as it wraps around. Through here is a bit of a shape change, just that variation and breakup, and then the thicker clumps, the smaller clumps, all that just adds to the realism of it. You can see through the arms, it's quite distinct as well. It's actually a bit smoother through there, and it gets longer as it goes up towards the elbow. You've got a distinct part line through where the forearms are, which is breaking off to the side and wrapping around, and then it's a little bit shorter on the inside as well. It's quite smooth through the hands, a little bit more clumping around the fingernails where it's a little bit longer. As we said, the chest is relatively smooth down that center line. On the side you can see there's some clumping coming through here, and there's actually a bit of a line, a visual line that you can see which is also in the reference. That is that transition from the longer fur on the back to the shorter fur in the belly. And the tail as well, a bit of variation through there. And a lot of that just comes down to the attribute painting. You don't need a lot of nodes to create the effect, but it's just how you blend those nodes together. Combining that with a couple of different variations in the scraggle, so it's not all uniform scraggle and noise.
As I say, it can be a very time-consuming process, but it's the attribute painting that really makes the difference in creating that more natural variation and realism that you see in the references.
The other thing that you would have noticed is that I've got different colours on certain parts of her fur. This has been set up in a way that we have different group IDs for each of the different fur sets. There's a couple of different benefits to that. So if I show you the graph, you can see that at the top here, I've got the main fur, I've then got the belly fur, I've got some extra fur on the face. These ones basically control the clumping, and then this one's the silhouette fur, and then they are all merged together and different effects are applied as it goes down. So, you know, we add the large clumping, we add smaller clumps, scraggle, some more micro scraggle, and again, they're all painted with the attribute maps. And the purpose for that is it gives us extra control both in the engine and in here when we're sculpting the fur. So you can see I've got those colored. The red fur is the silhouette fur, the blue fur is that belly fur, the greenish color is the main fur, and then the pink on the face is extra fur. Just to fill it in a bit more. We noticed in a few cases it wasn't quite rendering correctly in the engine how we wanted it to when it was getting very small. So by separating these out, it gives you specific control over certain parts of the face. If I just isolate some of that, I'll just take, say, the fur on the face, disable the silhouette fur. So you can see here, this is just the shorter, finer here on the face. It does blend in with the other areas, which I think is good. Again, it just adds a little bit more of that variation. Those finer, smaller, thinner hairs, they also add into some of that clumping structure with the slightly thicker, larger hairs from the body fur. And then, as we saw, the silhouette fur, it's longer, it's scragglier, a lot more noise, and that's what gives us that silhouette shape. So if we look at the silhouette fur, for example, having these separated out gives us control. So over here, this section, as I say, is the nodes that control that silhouette fur. It may be that we get it into the engine and we are trying to achieve a certain lighting look with that backlight, and we just can't quite get it to look correct. We don't want to apply a change to the entire Meerkat, because that may then make the main body fur look incorrect. So just separating those out where it makes sense to do so means that, for example, we can increase the width. So just as an example, I'll just make it 2 so it's really obvious. So now you've got very, very thick here, and that'll only apply to that set. As we can see, it didn't have any effect on the face fur, and it won't on the main fur either. So it just gives you a little bit more control.
The last little bits are the eyelashes and whiskers. For those, you just sculpt a guide curve for each one and then convert the guides to strands. Pretty straightforward. Basically, you just create your guide curves, generate the strands, generate your clumping and noise and other breakup, and then paint in the attributes to match the reference. There's a lot of tweaking of parameters and things as you sort of refine it further, but yeah, that's basically the general workflow. You can see here just the entire Yeti graph for the Meerkat. For the eagle, it wasn't quite as straightforward. Unreal's strand system only binds to geometry, so you can't bind a strand to another strand, for example, which is sort of what a feather is and kind of how Yeti handles feathers. But even then, you can't rig and animate a strand. So we tried a couple of ideas, but ultimately what we settled on was instancing a geometry spine as well as the strand-based feather at every location, and the two overlapped exactly, meaning that the barbs of the feather would align to the geometry spine. We then exported the geometry spine and built that into our rig. This meant that we could animate and deform any feather we needed to via its spine. We then exported the feather barbs as a strand groom, separating out the strand spine and the barbs. Over in Unreal, when we bound the groom to the eagle, the strand barbs would align and connect nicely to the geo spines in our rig. This actually worked out pretty well. It wasn't foolproof, there were definitely some issues here and there, but for the most part they weren't too noticeable. Once we figured out that part of the process, the creation of the eagle follows a similar approach to the Meerkat. Of course, we always start with reference, and then we place guide curves. This involved hand placing them for the larger flight feathers on the wings to a more procedural approach for the head and body. Then, instead of generating the strands, we instance hundreds of copies of the different feather types over the body, and for each one a matching spine geo, as we mentioned. If we have a look at the Yeti graph for the eagle, there's a lot more going on, but it's actually pretty simple. It's mostly just a bunch of separate groups of feathers which have been broken out to give me more control over each one. I made about 10 different types of feathers that visually represented the majority of the feathers on the eagle. So that's the primary, secondary, tertiary flight feathers, the tail, the body, the head, and then they kind of all get merged together to create the overall feather groom.
So this is our eagle with no feathers. Over here we have the source feathers. So as I say, we have multiple different types of feathers that represent the shape of most of the feathers basically. So if we come down to here, we can see that these are the different types. So that's a primary P10, and the shape was matched based off reference that we had for the feather types. P5, slightly different shape. P2, slightly different again. There's obviously variations between P5 and P10, so the 6, 7, and 8s, but they were very similar. So this was a good approximation between the two. So we just used that for all of those feathers between that on the wings. As an example, here's the secondary S6 feather, and as we discussed, the geometry that goes with it will match the same shape. So we could convert the entire groom into a geometry groom and you'd have the full card. This is more for helping creatures to be able to see it as a whole and to deform it without the use of Yeti. But the main part that was important is the central spine. So this spine is what the actual strands get bound to, and this was rigged and this part of the feather was discarded. The construction of the feather is pretty straightforward. The Yeti comes with a feather primitive, and that, as I said earlier, is basically a strand for the spine through the middle, and then additional strands that come off of it. And that's why we couldn't use it directly, as we can't bind these barbed ones to the strand spine. But in the properties section for this, we have a lot of control over the shape of it. You can increase and decrease the number of barbs that come off it, and there's various controls for the width, the curvature, the bending, that kind of stuff. Alright, so we can modify the shape of it by moving these vertices to create the shape to match the reference for the outer profile, and then change these values. So that's all I've done for these different ones. And then on the actual eagle groom itself, if we zoom out, we can see that copies of that same source feather get instanced over where we place the guides. So there's that P10, there's that P2, P5, secondary, so you get the different shapes through there. It doesn't match exactly, but it's it's pretty close. And then for the body, just a bunch of body feathers that are all instants across the surface, a bit more procedurally and less hand placed. For the face, there's an additional fur set on here, which is more of that traditional approach that we did with the Meerkat, just using the guide curves to create the face hairs that help blend in with the feathers. So what we have here is the secondary S6 feathers on the wings, and here's the section of the graph that controls those feathers. So what's actually happening here is we've got the geometry card that we built, which matches, and the Yeti feather, and the two of those are being combined together to ensure they have the same position and transform and properties, and they match. And then over here we have a switch node, so I can export the entire groom as a strand groom, which is what we put into the engine, and then by switching that we can convert the entire groom to our geometry card. So the card, which includes that important spine, was exported and sent to creatures, and they discard the outer part of the feather and keep the spine for rigging, and then we use that in the engine with our strand groom to do the binding.
So that was a very quick overview of the process. We'd need a ton more time to go into the ins and outs of the details, but if you have access to Yeti, you can open those source files and have a deeper look at how we built Molly and Martin. This groom was initially done to a film level, and for the purpose of being used in real time, it was what we considered a ground truth, and by that I mean I'm making the groom that matches real world values. So the number of individual strands, the thickness, the details along the strands, all have as close to real world values as we can discern. We just export to Unreal's ABC format from the Yeti menu. Over in Unreal, we just import like any other asset, but if you're new to this, there's actually a couple of important import settings. With the Maya Yeti setup, we need to do a -1 scale on X, -90 rotation on X, and 180 on Z. This simply corrects for the transform between the applications, and this will give us the groom as we see it in Maya, but with X forward in Unreal, and that'll match the orientation of our skeletal mesh, which is important for binding the assets later. Once the groom is in Unreal, we can just drop it into a scene and have a look. As I said, we start with our ground truth and then we can dial it back from there if need be. So I'll quickly go through some of the things that we did with the Meerkat to get it running a bit more smoothly in the engine while still matching as much of the visual fidelity as possible. For the most part, it just comes down to the number of strands and the number of points or vertices along the length of each strand, as well as balancing the thickness of the strands. By changing those three parameters, you can take a ground truth groom and have it run in real time substantially faster while still having it look pretty good. Strands is the obvious one. Fundamentally, less strands equals more performance. But before we start reducing the strand count, we reduce the vertices. The main thing that will be affected by changes in verts is the strand noise. That's the amount of frizziness and small changes in directions along the length of the strand. So we pick an average viewing distance, which basically means seeing how close to Molly we get throughout the camera sequence. For the most part, we see her from chest up or wider, with a couple of closer shots of her face. So with that in mind, we start reducing the number of verts and just visually look to see where we feel it breaks down too much while also keeping an eye on performance. I also have different fur groups in her groom so that we can refine that even further. So the belly, the short hairs on her nose, the longer guard hairs, and the main body fur, they all have different vert counts and strand counts to help with that optimization. The tiny facial hairs might only have 2 or 3 verts, while the longer body hairs that are a bit more frizzy might have 10 to 15, for example. Once we're happy with the vert reduction, if we still need to, we can start removing strands. Removing entire strands will have a bigger visual impact than the verts, but you can kind of compensate for that strand loss by increasing the strand thickness a bit. As you can see here, we reduce the strands and increase the thickness, and it still looks pretty close to what it was, but you get a lot more performance back. So with that said, if I put the two grooms into the engine side by side, we can see that they still look quite visually similar. You always lose a little bit of detail, but our optimized one is substantially more performant and it still turned out great in the final shot. Once we were happy with the groom shape, we started shading it. Talvin Cabezas did the shading work for the Meerkat and the Eagle, and he did a phenomenal job replicating the natural processes that take place in the fur to give the correct timing and release mechanisms that create that distinct meerkat patterning. Meerkat fur, as it grows, receives different amounts and types of melanin into the strand. This results in parts of the strand being lighter and darker and also coloured in different hues. So when it grows out to its full length, we get that variation of the browns and the reds and the whites and the blonde tones that make up the meerkat patterns. We set up different shading groups inside Yeti. These are called group IDs. It's the same concept as material IDs for geometry. So in Unreal, it separates sets of strands into groups that we can assign a different material to. So for example, we have a main body group and a guard hair group. So we can control the look of these independently in the engine. The guard hairs are what gives us that interesting backlit silhouette. So we can play with that in the engine within the context of our lighting setup to get that specific look right without affecting the other hair groups. The final step is to attach the fur to the skeletal mesh of the meerkat so that we can animate it. We do this by creating a binding asset. The main thing here is that the groom and the skeletal mesh in Unreal both line up. That's why we do that specific transform when importing. If the two aren't aligned, then the fur will be attached to the wrong part of the skin and it'll look incorrect when animated. You can either attach your groom asset to the scheme in the scene in the outliner or through a blueprint. We just generate the binding asset from the groom asset and assign the matching skeletal mesh. Once that's hooked up, we can just test it out on a walk cycle. We found it pretty helpful to get it onto animation as soon as possible. That's where we can see how the groom breaks. Is it moving correctly around the shoulders, the legs? Does it look good on Molly when she's standing up versus running on all fours? There was a bit of back and forth both for the Meerkat and the Eagle, tweaking the groom based on the camera angles, the skin deformation, just to see where things break down. This was particularly challenging for the Eagle, as controlling feathers in a rig is really difficult. We had to constantly add more feathers in when we saw gaps in the skin. The riggers did an amazing job turning around the Eagle in particular. It was not an easy asset. Once all the parts are in, your models, fur, shading, lighting, animation, that's where the minute fine-tuning comes in for the fur. Fortunately, as we're making an animated short, this meant that we had fixed camera angles and animation. So the fine-tuning was pretty straightforward in the sense that you kind of look at the rendered shot, identify issues, fix the issues, and it mostly ended up just iterating on some of the optimization stages. Did we lose too much detail in a particular area? Are the hairs on the face too thick? That kind of thing. By the end of it, we pushed it back a little bit more towards the ground truth, and it was still really performant. By optimizing some of the other areas in the scene, we were able to afford a higher quality groom and still have it run at 30 plus frames per second. Even though the final output of this project was a rendered movie, part of this test was to explore the performance of these types of assets for interactive and fully real-time mediums. So having it all running really well in the editor not only showed that we could make a pretty picture at the end, but that the workflow and speed benefits of real-time rendering were there, and that we could use similar quality assets in different contexts.
So that's a quick overview. It is a lot of information to compact down. If you're new to the strand-based tool, or if you're currently someone that's using cards to do hair and fur, this should give you a kind of an idea of the workflows and processes that go into it. If you're a groomer in the film industry, this is definitely another way that you can apply your skill set. As the tech moves forward, I think we're going to see it adopted more and more. As it becomes more performant, we'll see it in a lot more real-time applications. The other thing that I'm really excited about is to see people taking our content and reusing it in fun and creative ways, and sort of exploring the next step in the Molly and Martin saga. So thanks everybody. I hope you got something out of this talk. Cheers.